multiplication chapter, you have learned about one of the plot is called the, maybe I should ask you what is the plot. So let me stop this. I will move on to the next slide. I want you to tell me what is the slide, what is the plot. Just a second. Okay, so from here, okay, this is what you learn when we talk about summarizing the data and visualizing the data. So we have one variable, two variable, and three variable. So when we want to find the relationship between X and Y, as I mentioned just now, can you tell me it is about one variable, two variable, or three variables? Can you type in the chat box? Let me open my chat box. When we are going to test the relationship between X and Y variable, is it considered as one variable, two variable, or three variable? Just type 1, 2, 3 in the chat box. Okay, I can see many of you mentioned that two variables. Very good. So if you look at the two variables, we have scatter chart and line diagram. So scatter chart, it is the basic for your regression analysis together with the line chart. So when we combine these two together, we are actually looking at the regression line or the linear regression, simple linear regression. So what is the meaning? So it is like this. Let me draw it here. So if we have two variables, so the example that I gave you in the class is I talk about the weight and also the height. Okay, so let's say this is your X, this is your Y variable. So when we have the linear line, that means we have a straight line. So let me draw a straight line here. Okay, the annotate, there's no straight line. It's okay, I can just draw it. Okay, and then in your scatter diagram, you will have the dot, dot, dot in your scatter diagram, right? So in your scatter diagram, let's say you have here, you have here, you have here, you have here, some maybe below it. Most of them will touch the line there. Okay, so this linear line, okay, together with your scatter diagram, then you will have this regression line. Okay, this line chart, the red color one is considered as your line chart, and then the dot, dot, dot there or the cross there is considered as your scatter diagram. So when you combine them together, it is basically your simple linear regression. And then if you look at here, we have multiple linear regression. So we have simple, we have multiple. What is the differences between the simple and multiple? If you look at here, for simple linear regression, we have one dependent variable, we have one independent variable. So what is dependent variable and independent variable? Which means whatever changes in your X, it will affect the changes in your Y. Okay, so multiple means you have more than one X, meaning you have X1 and X2, for example. So when you have one Y, and then you have two independent variables, X1 and X2, it becomes a multiple linear regression. Or we can also call it as multiple regression. So in the equation form, you will see something like this. Y cap equals to beta 0, okay, plus beta 1, x1, plus beta 2, x2. Okay, so this is a multiple regression. For the simple regression, you will have y cap equals to b0 plus b1 x1. So this is like what you learn in your high school or in your secondary school, commonly written as y equals to c plus mx or mx plus c. So in your secondary school or in your high school, you learn about this equation. So what is this C? What is this B0? B0 is this line. When you touch the y-intercept, so this is your y, okay? When your x equals to 0, this point that when your x equals to 0, what is this y value? For example, let's say this is 3. Okay, let's say this point is 3 when x is 0. Then this B0 will become 3. So this is what we call the y-intercept. Okay, y-intercept is your B0. And what is this B1? B1 is the slope of this equation. It's the gradient or the slope. Okay, you can say it's the slope or it is the gradient. Okay, slope and gradient, they are the same. Either you can call it a slope or it's a gradient. Okay, so if you have more than one x, you have x1, x2, x3, x4. For your syllabus, usually we don't go up to x5. We only go up to x1, x2, x3, x4. Okay, so you may have a negative in front. It's possible to have negative beta x3. Okay, let's say you have negative beta 4 x4. Okay, then you will say, what is this B1, B2, B3, B4? They are coefficient of your regression. And all these value, so one of your friends asked in the chat group, in the WhatsApp group, how to get this value? All these B1, B0, B2, B3, B4, you can either calculate it or you can read it from your SPSS output or Minitab output or any software output that you can run regression analysis. Okay? So for this course, we are not expecting you to calculate it. You need to know how to read the output and how to interpret the trend, okay, how to interpret the regression, all right? And number 3 here, you see residual analysis and regression assumption. So there are 4 assumptions that using residual. Residual is the error, which means the differences between your actual y value with your expected y value. The differences between them. So let's say this one, if you look at this point that I draw here, okay, let's say this is your value. You fall here. So your y value is here. Okay, so this is your actual y value. But we use this red color line to predict. So if based on this red color line at this point, okay, when x equals to, for example, this is x equals to 5. When x equals to 5, the actual value here, maybe the y here is also 5. Okay, 5 and 5. But you are predicting using this linear line. The predicted value here, maybe it is 4. Okay, so these differences 5 and 4, the difference 5 and 4, it is your residual. The differences between the actual value and your estimated value. All right. And then we will learn how to build a good regression model. So how to know your regression model is good or bad? If you remember, last week, you learned about the direction and also the strength of your variable. Okay, so the strength of your variable, you measure it using correlation. Correlation, the value is in between 0, your R, if you remember your R value, it is in between +1 and also -1. Okay, in between +1 and -1. So can you remember it? +1 is strong positive relationship. -1 is strong negative relationship. In between there, we have 0. 0 means no relationship. And then in between 0 to +1, we have +0.5. So 0.5 is moderate relationship. So we also have -0.5, negative, okay, negative moderate correlation. Okay, and then I will say more than 0.7, or less than negative 0, more than positive 0.7 or less than negative 0.7, it is considered as strong correlation. So moderate is 0.5, strong is 0.7, and then low or weak, we use 0.3 as the cutoff point. Okay, remember you have 3 cutoff points, 0.3, 0.5, and also 0.7. Okay, so good means it is as close as possible to the positive one and also the negative one. That means it's a good regression model. But we are not looking at the correlation. We are going to look at the R square. Okay, R square, if your R is in between negative 1, okay, if your R is in between negative 1 and positive 1, when you square it, it will become in between 0 to positive 1. Okay, because negative 1, when you square it, it will become positive. Okay, so this one, we call it as coefficient of determination. Coefficient of determination will help you to decide whether your model is a good model or not. Of course, it's 100%. That means 1 or 100%, which means your model is a good model. Let's say if you get 0.2, 0.2 is very close to 0. That means your model is not a good model. So we will look at some of the example later. Okay. After that, we have this called regression with categorical variable. So just now when I say about this X and Y, last week I give you the example is, let's say this is the weight. Okay, weight is quantitative variable. Let's say this is the height. So height is also quantitative variable. So we have numerical and numerical, or quantitative and quantitative. What happened? What happened if your variable is a categorical variable? Meaning, for example, your X is the categorical variable, bad, moderate, good. So bad, moderate, good is a categorical variable. How to do it? How to form the regression analysis? We will do it using dummy variable. Dummy variable means it is not the real variable. It is a variable that you purposely created, okay, so that you can run the analysis. We call this as a dummy variable. But don't worry too much about dummy variable. We will not ask you to run analysis using dummy variable, but you need to know that for categorical variable, we have to use dummy variable. All right. And last but not least, we have regression model with non-linear term. So just now I say simple linear regression. I also say multiple linear regression. What is the meaning of linear? Can you type in the chat box and tell me? I actually say it just now, if you listen to me just now. What is the meaning of linear? So you see now we have non-linear. So first you need to know what is the meaning of linear. Can you type in the chat box? I'm still waiting for your answer. Very good. So Vinci say, which means it is a straight line. Yes, and you also say straight line. Very good. So when you draw this red color line, when it is a straight line, it could be going up, or let's say it's a going down trend, or let's say it is a horizontal line, or it's a horizontal line. So when we have this line, we call it as a straight line or a linear line. In English, we call straight line. In mathematics, we call it as linear. Okay, so when we say non-linear, which means your line is not a straight line. For example, let's say if you have a N-shaped curve, if you have a U-shaped curve, then they are non-linear. Okay, so we will go through this one by one. All right, so let's move on. Okay, so this one we already discussed. So these are the 5 common mathematical functions you need to know. Okay, you have to know. So what is the meaning you have to know? When you see this formula, you need to know this is an exponential function. When you see this formula, you need to know this is a polynomial function. So you have to know this finding. So let us go through one by one to see what is their differences. So exponential, when you have exponential, this is your y. The y variable is your dependent variable. Okay, dependent variable. And the x variable here, you see this x is at the power there, this x is here, and then this x is in the ln, inside the ln. This one, you not only have one x, you have x squared, you have x. And this one, the x, you have a power there. So all these x, they are your independent variable. Independent variable. Now, let's see how we recognize the equation. For example, if I have y equals to 2 multiplied with 5 power x. Okay, you look at this equation, my x is located at the power there. Okay, this type of equation, we call it as exponential equation. For exponential equation, the curve is like this. You look at the curve. It's increased, but it increased slowly. If it's decreased, it's also decreasing slowly. Like straight line, if you look at the linear line, this is what I written just now for the linear, simple linear regression. This is a simple linear regression. Let's say, for example, I have y equals to 1 plus 2x. Okay, so this is a simple linear regression. All right, so simple linear regression, if you look at here, it is a straight line. It is a straight line. Okay, so straight line, it increases faster compared to this exponential line. Exponential line, it is a bit slow compared to linear. All right, now what about y equals to ln x? Maybe I should erase this one not to confuse you. Let me try to put up the eraser. Okay, good. Okay, let's look at this. If you look at here, we have a L, a letter L, followed by a small letter n. A small letter L followed by a small letter n. This one, we call it as natural log or natural logarithmic. Okay, natural logarithmic, the equation is y equals to ln bracket by x. So for example, I can say y equals to, let's say, ln bracket 8. Okay, if you see this type of equation with the ln, then you know this is considered as a natural log, natural logarithmic or natural log, natural, N-A-T-U-R-A-L. Okay, natural log, L-O-G. All right. Now, if you see this type of logarithmic equation, the curve is something like this. Okay, the curve, it is not a straight line. It is a little bit curved like this. All right. What about polynomial? Polynomial, the shape is not a straight line. It is not a linear line. It could be something like this. It could be in a slightly different shape, maybe like going down and then going up like this. It could be something like this. It's also polynomial. So for polynomial, the x has a power more than 1. For example, x power 2. Okay, so you have x power 2, you have x here, and then plus c. So let me give you one example. Let's say y equals to 10x squared plus, sorry, the square, I'm not sure why it's like this, okay, plus, let's say 2x minus 5. Okay, so you always thought that this plus, we must follow plus. Not necessary. Your c maybe is negative 5. So it can have a negative value. All right. So if you have this type of equation, we call it as a polynomial regression or polynomial equation or model. And last but not least, we have this called power. So power, your x have the power, for example, power 3. Okay, so y equals to ax power 3. Sorry, my a, I need to replace it with another constant value. So let's say y equals to 7x power 3. So when I have this, the x have a power there. So it is a power, okay, power equation or power model. So when you have something like this, your curve is also a non-linear curve. Okay, it is also a non-linear curve. All right. Then you will say, Dr. Ted, why the exponential and the power look almost the same? When you have this type of curve that almost the same, you need to look at the equation given to you. So you compare the equation for this equation and this equation, you compare these two equations, then you will know when the x have a power, then this is a power equation. When your x is at the power side, it is an exponential equation. All right. So we will look at some example later. So your task is you need to know how to differentiate between exponential, linear, logarithmic, polynomial, and power when you look at the equation or when you look at the trend line given to you. All right. So that is your task. Now, what about the terms multi-collinearity? When we talk about regression analysis, in your machine learning, you have one very popular algorithm called logistic regression. Logistic regression is also one of the regression. Okay, just now we have this regression, right? Okay, so just now I say, I need to write one more time. Okay, if simple linear regression, you have this. Okay, let's say 5 plus 2x. Okay, if multiple linear regression, you have this. Let's say 3 plus 4x1 plus 5x2. For example, I just randomly give some example. So I say if your variable, if one of your x variable, let's say your x variable here is a categorical variable, this can be a categorical variable, then you need to use dummy variable, okay, when you do the analysis, dummy variable. Okay, now let's say if your y variable, remember for linear regression and multiple regression, all your x and y, they are numerical variable. Numerical variable mean your quantitative variable. Okay, they are numerical variable or quantitative variable. So if your x is a categorical variable, you need to use dummy variable to replace it. If your y is a categorical variable, for example, your y is yes or no. Yes or no is categorical variable, right? If you ask to choose yes or no. So yes or no is a categorical variable and you have two choices. Two choices, we actually call it as binary. Binary means two choice. Okay, binary. So let's say if you have something like this, y equals to 5 plus 2x, but your y is a binary variable, then this become a logistic regression. Okay, logistic regression. So logistic regression, the y is a categorical variable with two choice, two outcome. For example, yes or no, defect, no defect. Okay, so whenever you have two choices, then it can become a logistic regression. Okay, so multi-collinearity. So what does it mean by this term multi-collinearity? So by looking at the English term, okay, I need to call out my annotate. By looking at the English term, multi-collinearity. So linear, okay, linear. Okay, so multi here meaning there are a few independent variables, okay? They are actually used to explain your y variable. So what is the meaning? If you look at here, okay, we start with this one. I want to start with the bottom right. Look at the bottom right. Okay, this is your y variable. Imagine the big circle is your dependent variable y. And then you have 3 independent variables, x1, x2, x3. Okay, x1, x2, x3. x1 is the one that, okay, you see this one? This one, the one that my mouse is moving here, the orange color one is your x1. Not orange, sorry, your yellow color. Your yellow color one is your x1. And then the red color one is your x2 circle. The red color one is your x2 circle. And then the blue color one is your x3 circle. You notice that for the variable x1 and x2, both of them can explain your variable y. And they are overlapping. The orange color is the overlapping of the red color and the yellow color. So when this happens, that means there is a multi-collinearity between your x1 and x2. Okay, so multi-collinearity present or exist whenever your independent variable, so your x1 and x2 here, they are highly correlated with one or more of the other variables in your independent variable. So when this happens, if you remember just now I say R squared, okay, R squared, your coefficient determination, okay, coefficient of determination. Let me type in the chat box, coefficient of determination. Okay, when the coefficient of determination R squared is close to 1, that means it is very good. But when it is too close to 1, very, very high, very near to 1, you also need to worry because there could be a multi-collinearity happen. So in machine learning, when you're facing this problem, meaning variable x1 and x2, they are highly correlated. They are very similar. They have very similar characteristics. So if this happens, what can you do? Can you tell me in the chat box if you have x1, x2, x3 now, and your x1 and x2 extreme multi-collinearity. Multi-collinearity is not good. Okay, I repeat, multi-collinearity is not good in the machine learning or in the regression. So if you have this one, x1 and x2 very similar, what can you do? Can you type in the chat box and tell me? Very logic and straightforward answer. What should you do? Very, very good. Just remove one of the overlapping variable. That is the most straightforward answer. Thank you. I don't know what is your name. Griffith, Yong Wei, Chun Long, and also Things. Things say replace. Okay, you don't need to replace because x1 and x2 already same. So why you want to replace with another new variable? So the better way is to remove one of them. You either remove x1 or you remove x2. It will reduce or solve the multi-collinearity problem. Okay, so let's look at how do we mean by no multi-collinearity. So this is good. This is not good. Okay. So why this is good? Because you have x1 explain your y variable, x2 explain your y variable, x3 explain your y variable, and there is no overlapping between them. So this is the ideal case. So for example, let's say my y is my house price. Okay, let's say the y is the house price. So what are the factors that will affect my house price? So maybe x1 is the location, the distance. Okay, the distance. Maybe I shouldn't say location, I should say distance. So let's say this is distance. Okay, distance will affect the house price. Then what about x2? Maybe x2 is the size. Size of the house, if your size is bigger, of course, the price of the house is also higher. So price will affect the dependent variable, the house price. What else? maybe your factor number 3 beside the distance, beside the size, maybe number 3 is the number of facility, okay? Number of facility in the condominium. So if you have more facility, of course, people will like it and the price will be higher. So these 3 factors, they are not related to each other. So, and 3 of them contribute to your house price. So there is no multicollinearity. So if you have something like this, X1 and X2, they are overlapping the orange color. X2 and X3, they are overlapping the purple color. So this one, we still have multicollinearity, but it is called a moderate multicollinearity. So moderate multicollinearity, we also can remove one of them. You will observe X2 and X3 a little bit of overlapping, X1 and X2 more overlapping. So you may want to decide to drop your X2, to delete your X2. After you delete your X2, your circle will become like this. X1 is here, and then X3 is here, and there's no overlapping between your X1 and X3. So for moderate multicollinearity, you can also drop one of the factors with high collinearity. So how to check the collinearity? Usually we use the VIF reading. Okay, VIF. VIF reading, when you have a high VIF, is indicate high multicollinearity. Okay, if you have high VIF, that means high multi or extreme multicollinearity. All right. Okay, so let's move on. So the second thing that you need to know is underfitting and overfitting. So this question is also very, very popular in the final exam and in your midterm exam. So you imagine that you are wearing a new cloth. So if a person wearing this coat like this is the most comfortable. We call this as a Goldilocks zone. Okay, very comfortable. Let's say if you are wearing size, if your size is about 70 kg. So 70 kg, maybe we will wear a L size shirt. So L size is suitable. So you will feel this person wearing this shirt very suitable. Let's say you are supposed to wear L size, but you are wearing M size. You are wearing S size. Maybe I should write it up. Okay, so you are supposed to wear L size, but you wear S size. You can put on the shirt, but you can see the button almost coming out. And it's very difficult to breathe. When you wear it, you need to hold your breathing. So S size is too small for you. So this is called overfit. When you are wearing, you need L size, but you are wearing, let's say, XL. XL size is too big for you. So this is called underfit. Okay, it is too big for you, too loose when you wear it. So same thing for machine learning. When you draw your straight line or when you draw your trend line, we want to find out which is the most appropriate fitting. So let's say I have this circle dot and I have this cross. So if I draw a red color non-linear line here, okay, you see this non-linear line, I call it as suitable fitting or appropriate fitting because this line separates the circle with the cross. Although maybe I can still detect like 2 cross inside here, but it is still okay. Overall, generally, I can separate between the circle and the cross. So you can call this as appropriate fitting. You can call this as a good fitting. You can call this as a parsimonious model. Parsimonious means simple and the most suitable. Parsimonious means simple and the most ideal model. Or in English, we say just right fit. Okay, just right fit. Now, what about this underfitting? Underfitting, when I want to separate this circle and the X, I use a linear straight line. So if I draw this linear straight line, as we all know just now, this is simple linear regression. So simple. It is very, very simple to draw it. The equation is just a straight line. But you can see there are some green color on the top there. There are some circle at the bottom of the line. So it cannot well separate the circle and the cross. So in this case, we call it as underfitting. On the right side, if I draw a curve, a non-linear curve like this, it is very complicated, right? Compared with this straight line, this is a very complicated line or a very complex line, complex equation, complex model, complicated. Okay, so if you do this, it is very good because you can separate all the circle on the right side, all the cross at the left side. But overall, it is not a good model. We call it overfitting model. Why? Okay, why? I'm going to explain this. So first thing, I need you to memorize the term. Underfitting means it is too simple. Okay, too simple, like you are wearing the clothes, you can wear it, but you still have many empty place there. Overfitting means it is too fit. You see, fit until follow exactly. So let's say another person try to wear this shirt, he or she will not be able to wear it. This one, let's say if the person with size L, size M, he or she can wear your shirt. So this is too simple. This is too complicated. So what we want is, we want something like this. Okay, so in the underfitting case, we call it high bias but low variance. You need to remember this, high bias and low variance. What is the meaning of high bias? High bias means, you see, there are some of the circle fall on the cross side. There are some of the cross fall on the circle side. This is what we call high bias. Bias means not fair, right? So not fair, high bias. But it has low variance. Low variance because it is very simple straight line. Okay, for the right side, overfitting. Overfitting, it has a very high variance, but it has a very low bias. Okay, it is opposite. You see this one have low bias for overfitting. You may want to write down low bias for overfitting, low variance for underfitting, high bias for underfitting, high variance for overfitting. My suggestion is, you don't try to remember two. You remember one side. Okay, you remember one side. When you're overfitting, it is low bias, high variance. Why we say low bias? Bias is not fair, right? This one is very fair because all the circle on the circle, all the cross at the cross, but it has a very high variance. I'm going to explain to you why this is high variance. This one is appropriate. Appropriate means the ideal case. The variance is okay. The bias is also okay. So low bias, low variance. Okay, at the center one, low bias, low variance. Low bias, low variance. Okay, you need to remember this. You need to know how to explain it as well. So let's say I'm trying to explain this to you, why high variance. Let's say if this model, the red color regression line, okay, the red color regression line is your model. When you do your training in machine learning, we have training data set, okay, and then we have testing data set. Training and testing, or you can use training and validation, it doesn't matter. Okay, so let's say if you use this model for training, then later on, when you have the testing data set, very unlikely that your testing data set can fit into this complicated model. So the variance between the testing and the training will become very high. Okay, but if you have this one, a very simple model during your training, okay, so later on, when you have your testing data or when you have your validating data come in, it's very likely that they can fit into this line because you only draw a straight line, right? So the second set of data coming in, it is also most likely this line can separate between the two data set. Okay, between the two characteristics. Okay, so this one is too simple. This one is too complicated. This one have high variance. This one have low variance. Okay, let me give you another example. So, for example, when you go for exam, okay, when you go for exam, before you go to the exam, you will do many exercise. You will do many questions. So let's say your question, okay, the question that you do is a very complicated question. Okay, so in the exam, if I modify the question a little bit, you already cannot answer it. But on the left side, before you go to the exam, you do some quite straightforward question. So when you practice many type of very straightforward question, when you go for the exam, you see this type of question, you already can easily answer it. Okay, so this one, it is too simple. This one, it is too difficult. When we change to a little bit more difficult question, you may not able to answer. When we change this to a little bit more simple question, you will not be able to answer. So the best scenario is when you do your revision before you go for certain exam, you do some difficult question, you do some simple question. So when you have your exam, there will be some difficult question, some simple question, then both of them you will be able to answer. Okay, so this is the best model that we are looking for. This is the best. Okay, this is underfitting, this is overfitting. All right. So any questions about underfitting and overfitting, you can write it in the chat box and maybe Dr. Ng can help us to answer. Okay, I think there are some questions in the chat box. Dr. Ng, if you can help, thank you. Okay, so let me summarize for the regression analysis. You have simple linear regression. So simple linear regression means you only have one X, you only have one Y. Okay, you see here, one Y, one X. Multiple linear regression, you have one Y, you have more than one X. For example, X1, X2, until X. It can be go up, as I say in our syllabus, normally we just go up to X4. Okay, now another is regression with categorical independent variable. So as I told you, if your independent variable, let's say X1 is a categorical variable, then you need to use dummy variable. And you may also have non-linear regression. Non-linear, for example, when you have X power 2, when you have X power 3, when you have ln X, ln X just now, okay, that is considered as non-linear regression. All right, so from the equation, you need to know how to explain which type of regression is that. All right. Okay, so now, simple linear regression. So in the simple linear regression, there are a few things that we usually can do or can need to know for the regression. So let's look at this one. A simple linear regression, when you see I write it, I usually put a cap on top of it. What is the meaning of this hat or cap? Okay, you see I always put a cap here, then I put, for example, 5 plus 3x. So why I need to put this cap here? The cap here meaning estimate value. So why it is an estimate value? Because when we write our regression equation, usually we are using the sample data. Remember, we have sample and population. We use our sample, okay, and we try to estimate it for our population. So the cap there, okay, the cap there represent the sample value. Okay, so this linear regression come from the sample data. So how we actually write the simple linear regression? We use the least square method. So what is the least square? Meaning we try to reduce the error. We try to reduce the residual. We want the actual y value and the estimated y value. Their differences should be as smallest as possible. So least means small. Okay, small. We want it as small as possible. So if it's as smallest as possible, that means all your dots should fall on the straight line. Okay, if all the dots fall on the straight line, then your residual will be very small, meaning the difference between the actual value and the predicted value will be very, very small. Okay, and then we use the scatter plot. So this is the scatter plot, okay, to see the linear regression, to see whether it's in the increasing trend, decreasing trend, or no trend. After that, we draw the prediction line. So scatter plot means when you draw this one, this is your X, this is your Y. So when we say scatter plot, in the previous chapter, you only see all the dot, dot, dot. Okay, you only see all the dot. And then when we have prediction line is a straight line that you added. So let's say I draw a straight line here, the blue color straight line. This will be my prediction line. Sorry, my straight line is not very straight. I cannot find the straight line there. Okay, and then after that, we will check the residual assumption. So these are the steps when you do your linear regression. So you should learn this more detail in your statistics subject. You have one statistics subject that learn about regression. You also learn this regression in your machine learning, the programming part. So this is the basic concept. But how to run it, you should learn it in your statistics. So residual analysis, there are 4 assumptions, L-I-N-E. I put in L-I-N-E for you to easily remember. L stands for linearity. Okay, I stand for independent. N stand for normality. And E stand for equal variance. So if these 4 assumptions fulfill, or is these 4 assumptions you follow, then you can use the linear regression. Okay, so first thing, you write the equation. Second thing, you may look at the scatter plot, and then you add the prediction line, and then you check the residual analysis assumption. After that, we want to know whether the model is suitable or not. Whether this straight line model is suitable or not. If yes, then you can use your model for prediction or estimation. If no, no meaning straight line is not suitable. Maybe it is not a linear regression. Maybe it is a non-linear equation like this. Okay, so if no, you cannot use it for prediction. If yes, you can use it for prediction. Usually the first thing the question asks you to do is to write the equation. So all of you must know how to write the equation. So if you are given the output, then you will be able to fill out the B0 and B1. Okay, so for example, y cap equals to 3 plus 8x. Okay, so first thing normally is to write the linear equation. Second thing is use it for estimation. So let's say if I give you the value, if I say the question say given that the x is maybe 1,000 square feet, okay, 1,000 square feet, I want to predict what is the price. Let's say y is the price of the house. Okay, x is the square feet. So given x is 1,000 square feet. Now, if I want to rent a house, 1,000 square feet multiplied by 8, I got 8,000. 8,000 plus 3, I got 8,000 I think it's not logic. Let me change it to 100 square feet. But 100 square feet is a very small room only. So let's say 100 square feet times 8, I have 800. 800 plus 3, I have 803. So for every 100 square feet, the cost is, let's say, Ringgit Malaysia 803. Okay, so if I give you the X value, you will be able to predict what is the rental cost. So now you want to rent a house. You want to estimate every 100 square feet, what is the cost? So you can calculate using your formula. So first is to write the formula. Second, use your formula to do the prediction or to do the estimation. And number 3, we want to know this model is good fit or not good. So the R square, if it's very close to 1, then it's a good fit model. If your R square is very low, let's say below 0.3, that means your model is not a good fit model. Okay? So this is what regression analysis, what we usually report and what we usually see it. Now, let's move on. Okay, so this is the cutoff point value for the coefficient of determination R square. So 0 means no correlation. Okay, above 0.7, remember when we talk about R, our cutoff point, don't confuse. R is for correlation. Correlation. Okay, the R value is in between -1 to 1. When we say R square or the small letter R square, it doesn't matter capital or small letter. The R square value, why is missing? Okay. The R square value is in between 0 to 1. Okay. The R value is in between -1, to +1. Okay. So earlier on, we say this is the strength of the variable. So R, we have 3 cutoff points, 0.3, 0.5, and 0.7. These represent low correlation, moderate correlation, high correlation. So when we change to R square, okay, so 0.5, you square it is about 0.25. Okay, but it doesn't look like this. It uses a different way. So we better follow this one. So 0.5 is the center. So 0.5 represent moderate. Okay, moderate correlation based on the determination. All right. And then less than 0.3 is weak. So for this case, they are using in between 0.5. Anything that less than 0.5, they are considered as a weak correlation. So you don't need to remember very weak. You roughly know about this value. It is considered as weak. Okay. And then if it's above 0.75, it is considered as strong correlation. Okay. I think you don't confuse yourself. We use back the same value. It's easier. Okay, we use back the same value for the correlation and the R square. So 0.5 is still considered as moderate. Very close to 0.7, higher than 0.7, we consider as high correlation. Lower than 0.3 or very close to 0.3, we consider it as a low correlation. So we better use this one for R and R square. Okay, so to make yourself, not to confuse you, we use the same cutoff point. All right, this one they separate into very detailed, very small difference between them. All right. Okay, so this is what we looked at last week for the coefficient of correlation. So straight line, linear line. Okay, this one strong correlation. Something like this, moderate correlation. Something like this, weak correlation. Something like this, no correlation. All right. Okay, now let's look at the assumption. So assumption, when we look at the assumption, most of the time we look at the residual. Residual is similar to the error. Okay, so it is the difference between the actual value. This is the actual y value. This is the estimated y value. The one with the cap on top of it is the estimated value. So linearity, I think I better don't use this word to explain. I will show you the picture. But L stands for linearity. I stand for independent, but it's the independent of the error, not independent of the independent variable. Normality, equal variance. Equal variance in statistical term, we also call it as homoscedasticity. Okay, if not equal variance, we call it heterogeneous, drasticity. But you don't worry, you just remember equal variance and not equal variance. Okay, so let's look at this diagram. Okay, let's say you have X and Y. You plot your X and Y, you see something like this. Don't look at the right-hand side. Now I'm looking at the left-hand side. Let's look at the left-hand side first. If you draw a straight line for X and Y, you see something like this. So meaning it is not a straight line. Okay, if you look at this one, it is not a straight line, right? It is actually a curve. So this is not linear. Okay, if you draw a straight line, on the right side now, X and Y, you draw a straight line. This is a different set of data. This data, most of them touch the line, but some of them didn't touch the line. However, you can see it is in an increasing trend. Okay? Okay. You need a short break for prayer. I think it's okay. You can move to the prayer, but I will continue to discuss. Later on, you can watch the recording for this part. Okay, because today's lesson is quite long. I don't want to stop in between. We already stopped. We already late by 1 hour to start. Okay, you can leave for prayer. I will share the recording later. Okay, so from here we can see maybe this is a moderate correlation. Okay, how to look at the residual? Residual is the differences between the actual value minus the estimated value. So you use the actual value minus your estimated value as your y variable here. And then your x variable, you still use back the x variable. So when you draw it, you will see something like this. So this is also not a linear trend. So you can observe it from your original X versus Y. You can observe it using a residual, a residual analysis. This set of data on the top, this is the original data set. When you draw the residual versus the X, you see all the points are very, very close to the center here. Normally, the center here is when Y equals to 0. Okay, so they are very close to y equals to 0. So they are focusing on that area. So their residual is follow a linear trend. So this is what the ideal case, linear equation. When you see something like this, you know the assumption of linearity is not fulfilled. So linear regression is not suitable. Okay, linear regression not suitable, linear regression not suitable, linear regression suitable, linear regression suitable. All right, so this is how you see it. Let's move on. How to check independent? For independent, we can look at the residual versus the x. You see here, when the x increase, the residual is moving in an upward trend. In this case, when the x increase, the residual is moving in a cyclical trend. We call this as a cyclical trend. So they are not linear trends. In this case, on the right side, you see all the residual are very close to this center point of the residual. So they are, they are very close to the 0 point or very close to each other at the center point. So in this case, your x and your y are not your x and your y, your residual. Your residual fulfill the independent assumption. Why we say not independent here? Because when x increase, the residual increase. In other words, residual depending on the x. In this case, when x increase, the residual also increase in a cyclical trend. So the residual depend on the x. So these two cases, residual is not independent. On the right side, when your x increase, your residual is about the same. So for example, let's say my residual here is in between 3 to 4. Okay, in between 3 to 4. So when my x increase from 1, 2, 3 until 10, okay, my residual is still in between 3 to 4. So the residual does not depend on the x. So that's why we call the residual is independent. Okay, now let's look at the next assumption. Okay, so check for normality. How to check for normality? Normally in the SPSS or Minitab, we have one output called QQ plot, okay, QQ plot or the PP plot. So this plot can help us to check whether it is normal or not. If it's a normal distribution residual, it will fall on the straight line. All the dots should touch the straight line. That means your residual follow a normal distribution. If you see something like this, okay, so this is your straight line. When your dot, let me change another color. When your dot is falling here, 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 and then maybe here is going up. Or maybe your residual, I change another color, green color, is something like this, and then only touch the line, and then left the line. So the blue color and the green color, they are not normally distributed. The red color, they are normally distributed. So normally distributed means it touched the straight line. Okay, it touched the straight line. Now, let's look at the last one. How to check whether it is equal variance or not. If you remember, I say for the variation, variance, range, standard deviations, we want it as smaller as possible. So as smaller as possible means, let's say for this one, you have your x, okay? So your residual is always constant. So let's say this value, this is my residual. So let's say this point, the residual is 0.2, okay, 0.2. So all my point, it is very close to the residual of 0.2, maybe in between 0.15 to 0.25. So I have a constant variance value when my x is increasing. So I can say my variance are equal. On the left side here, you see, my variance originally is like this. And then when I reach my x is a little bit bigger, my variance is become like double already. When my x is go until the end there, my variance already increased like about 4 times of this. You see the gaps. The gaps represent this gap. This gap represent the variance. So this small variance, this is like double up the variance already. This is like 4 times of the variance already. So if you see this type of trend, that means the variance is not constant. Okay, the variance is not constant. Sometimes it could be something like this. Okay, the trend like this. So the variance at the beginning is very big, and then it become small, and then it become very small. This type of trend we also call not constant variance. Only this type of trend we call it as a constant variance. Okay, so altogether, if these 4 assumptions, L linearity, I independent, N normality, and E equal variance. If this L, I, N, E assumption is fulfilled, then your linear, why I cannot, okay. If this L, I, N, E assumption is fulfilled, that means your linear regression or simple linear regression is a suitable model or a suitable trend line. If one of them does not fulfill, that means your regression model is not suitable. So you must fulfill all the 4 assumptions. All right? Okay, so if we look at this one, it is for multiple regression. So same thing like the simple regression. First, you write the equation. But in this case, you have more than one x. You have x1, you have x2 until xk. Okay, so if your data is not numerical variable, for example, you have the qualitative or categorical variable. If you have the categorical variable, then you need to use dummy variable. Okay, so don't worry about this. As I told you in your syllabus, you are more focusing on the quantitative variable. So you need to check the LINE assumption. You need to know whether your model is suitable or not. So first of all, we will use the F-test to check the whole model is suitable or not. If the overall model is significant, so meaning this is your model. If this model is significant, that means you can use it for prediction. So you use it for prediction, you will estimate your beta value. Okay, so if I'm given you the x1, x2, you can estimate the y value for me. And you also can use the R square value to check whether your model is a good model or not. Okay, so same like your linear regression, the only thing is you have more than one x variable. Okay, so this is the multiple regression. So how to choose? They are simple linear regression. They are regression with categorical independent variable. They are multiple regression. They are logistic regression. So this type of regression is the most common regressions that you use. Of course, other than that, we have Pearson chi-square regression. We have multiple logistic regression. We have log linear analysis. The one in the gray color is not covered in your syllabus. I repeat, the one in the gray color, you can ignore it. You need to know especially simple linear regression and multiple regression. Dummy variable, don't worry, we usually don't ask you to do the analysis. We just want you to know if you have one of the independent variable is categorical, then you need to use dummy variable to replace it. Okay? So for dependent variable, it has to be continuous variable. For independent variable, if you only have one x, you use simple linear regression. If you have 2x, 3x, 4x, you use multiple regression. It is quite straightforward. All right? Okay, so why we need to learn regression? Because in the machine learning, you have supervised machine learning, unsupervised machine learning, and reinforcement. These two are the most common one. So regression, linear regression, polynomial regression, they are considered as supervised machine learning. Logistic regression also, they are in the supervised machine learning. So this is why you need to understand the concept of regression. So if you look at here, there are quite many types of regression, including linear regression, polynomial regression, okay, and then the logistic regression. So the rest, let me check. Okay, the rest you don't need to worry too much about it. Okay, don't need to worry too much about it. Linear regression, polynomial regression, multiple regression, logistic regression, you need to know a little bit. All right. Okay. So overall, in this chapter, first, you need to know which type of trend line is that. So let us recap. You have exponential, linear, logarithmic, polynomial, and power. And then you need to know how to see whether there's a multicollinearity or not. Multicollinearity means there are at least two independent variables. It could be 3 independent, 4 independent, 5 independent variables. They are overlapping, meaning most of them are used to explain the y variables. Okay, and you need to know how to differentiate between underfitting and overfitting. Underfitting, you actually have a very high bias. High bias because you see many of the circle fall on the left side, many of the cross fall on the right side. So it has a very high bias. Overfitting, you have a very low bias. Okay, all the X on the left side, all the X on the right side. But variants are different. For underfitting, the variance is very low. Okay, low variance meaning when you have a new set of data, it can be easily fit using this linear regression. Whereas for your overfitting, the variance is very high. The variance is very high, meaning when you have your testing or validation data coming in later, they are very difficult to fit into your model. Okay, so your variance is very high. So what we want is low variance, low bias, which is the ideal model. The center one is the ideal model, the appropriate fitting. All right. And then you need to know how to write the simple linear equation. You need to know how to write the multiple regression equation. After that, you check the assumption, LINE assumption. After that, you need to know whether the model is suitable or not. So after you know the model is suitable, you can write the equation. You can use the equation to do the estimation. Do the estimation means if I give you the X1 value, you can predict the Y value. If I give you X1, X2, X3, you can predict the Y value for multiple regression. How to know whether your model is good or not good, fit or not fit? Normally, we use the term fit. We don't say good or not good. We say fit or not fit, FIT. So R squared high means is good fit. R squared low means it is not good fit. So it is same for the linear and multiple regression. So for the regression type that you need to know in your syllabus is simple linear regression with one X variable. You also need to know the multiple regression with two or more X variable. So if your variable have the categorical variable, we need to use the dummy variable. So this is what you need to understand and know for this chapter about regression and the trend line. I think I will give you a 5-minute break. Okay. Before that, let me remind you 17 December. 17 December will be your test. So please record, please put it into your mobile phone, 7:30 to 8:30, because we want to give way for those who go for prayer. You will be given 1 hour to answer. We will put the question into e-learning for the physical student, ODL for the EMB student. Altogether, 20% out of 100% in this course. And there are 30 objective questions. Objective means multiple choice question. And the chapter cover is chapter 1, 2, 5, and 7. So this chapter, trend line and regression analysis, is covered in your syllabus. Okay? All right. Okay. During the test, you no need to switch on your WebEx. You don't call us, don't WhatsApp us. Dr. Ng and I will not entertain. Imagine there are about 700 of you. So when you do the test together, each of you text us, we will not be able to answer. This is not an open book test. You should do it by yourself. Okay? If you seriously facing problem, you totally cannot enter to the test and so on, you can turn on your WebEx and meet us, discuss us in the WebEx. We will stand by inside the WebEx. For those no problem, do not join the WebEx so that we can help the one that got problem. Okay? Please note that when the test is over, when the time is 8:30, the system will stop and automatically your answer will be submitted. So let's say if you answer halfway, there are 20 questions, let's say, there are 30 questions. Let's say you answer until question number 20. Don't worry, it will automatically save. So don't ask us. You no need to message and ask us to check whether you submit or no submit. We are not going to answer you. Okay? So that is the rule and regulation for your test. Any question about your test, you can ask me now during the 5-minute break. Okay, we will have a 5-minute break. If you have question about this chapter, if you have question about your test, please post it in the chat box. Okay. My helper here, can you please help to put out the timer? Thank you. Susan, are you here? Can you please tell me to put out the 5-minute timer?
Okay, Dr.
It's okay, I already put.
Thank you, Dr. Ng.
Okay, I'll share my screen now. So we are going to do the exercises for chapter 5. So we are going to do quizzes. So by the way, this is not a quiz. This is not a quiz. This is just exercises for chapter 5, trend lines and regression analysis. Let me share my screen. So can you please join? If you like the piano music I can play during the game. Okay, so please join. So this is an exercise, yeah? So 15 minutes for 21 question. So please work on it. This is an exercise for chapter 5. Now, in terms of the chapters, yes, it covers chapter 1, chapter 2, chapter 5, which is including the exercises that here, what you're doing later will be also covered in midterm, and also chapter 7, data mining. So if you have been doing the quizzes and also the exercises, right, somehow rather you are ready for the midterm test, because the midterm test questions, right, are very similar with the one that you have been doing. Sorry, I couldn't switch on my camera because I forgot to bring my webcam. You all can hear me, right? Can you hear me?
Yes, Dr. Ng.
Thank you. So please join. I will start in 2 minutes. Okay, in 2 minutes time we will start. So please join. This is a very important chapter because this is also covered in the midterm test as well as the final exam, like what Dr. Tan mentioned earlier, right? 30 marks for your final exam is actually from chapter 5, okay, regression analysis and trend line. Okay, we will start in another minute. So you have 15 minutes to do the questions, yeah? 15 minutes. So again, this is not a quiz. This is not a quiz. This is basically exercises for chapter 5. So you don't have to be so panic. There's no marks taken for this exercise, but the main purpose is for you to get prepared for the quiz because according to the teaching plan, next week we have quiz. The quiz will cover chapter 5 and chapter 6. Okay, so take note. Next week we have quiz, right? So quiz 3, our final quiz, will cover chapter 5 and 6. So please take note on that. So take this as an opportunity for you to learn the questions for chapter 5. Okay, thank you, Dr. Tan. Okay, so I will start now. Okay, let's take probably another 1 minute, then we will start. Okay, we will start now. So for those who are still joining, you can always try to join. Probably I can type the code. You can join later on. Okay, I will start now. Oh, give me a second. Hang. Give me a second. Let me try to reload. Okay, please start now. demo, has anyone completed? If you have completed, can you please give me a thumbs up? Anyone completed? Okay, good. Can you help to check how many minutes left? Because my site is actually quite hanged. Can you check how many minutes left? Can you please type in the chat box? Approximately how many minutes? So we have 2 more minutes, then I will stop the lesson. Because this lesson method will allow you to know the real answer. So when you do it properly, right, you should be able to get the answer right, yeah?